Over time, Microsoft has generated a large number of data access APIs, and ADO.NET is just the current one. This one supplements DBLib, ODBC, DAO, RDO, ADO. They all still exist. I mean, actually, no one uses DBLib anymore. It's from prehistoric times. But the rest of them still exist and can be used. RDO was really meant only for Visual Basic 6, and so has fallen by the wayside. But the others you can still use. ADO, the previous most bestest API for working with data, works fine, but it requires COM and Windows on both ends. That is, anyone creating data and anyone consuming data has to have both COM and Windows installed, which doesn't make it work real well in the web browser world. In addition, record sets don't travel well. That is, ADO record sets don't travel well across the internet. You have to convert them to some serializable format and then deconvert them on the other end, and it's not good. In addition, the fact that ADO requires you to be connected to really do anything, and most of the time in ADO you just stay connected, that's hard to work with in a multi-user, real-time environment. So we won't even talk about it. We're done with ADO. ADO is a 1990s technology, and in this century, we're dealing with ADO.NET. ADO.NET requires a slightly new mindset if you're coming to data from a more connected environment. For example, if you're an Access developer moving to the web and you need to use ADO.NET, you have to think about things in a different sort of way, because in the Access world, you were always connected to your data all the time. ADO.NET assumes that most data access is disconnected. You get your data, you hold it offline, make changes, send the changes back, connecting for the shortest period of time you can when you're done. In addition, any data transport that needs to move your data from one place to another outside your local network will use XML. That is, ADO.NET knows how to serialize itself as XML so the data can be moved from one place to another. ADO.NET solves the problems of working with transport because it uses XML under the covers, and of course XML has no runtime or transport requirements. There's no special code that's required to move XML across the internet. Remember, XML is just text. Now I will mention that more current technologies, for example WCF, Windows Communication Foundation, provide a nice way to communicate across the internet, across disconnected platforms, and WCF does support binary transmission. So WCF would support transporting an ADO.NET object live across the internet. But again, that's a topic for a different day. Here we're using standard ADO.NET and letting it handle how it serializes its data. In order to work with ADO.NET, you'll have to become familiar with some of the classes in the ADO.NET technology. You'll always start with the namespace, which is the root namespace for working with data in ASP.NET, which is system.data. Now, within the system.data namespace, there are multiple database-specific namespaces, such as system.data.oladb for working with OLADB data sources, and system.data.SQL client for working with SQL Server databases, and there's system.data.odbc, which we won't actually cover here, for working with ODBC data sources, and more to come. But actually, there already are other namespaces. For example, Oracle. There's a system.data.oracle namespace, or whatever it's called. There's a Microsoft version. There's an Oracle version for working with Oracle databases. In any case, this is an extensible architecture so that anyone could write their own data handling namespace for any database, and you could use it within ADO.NET. For our purposes, we'll be focusing on the two basic Microsoft technologies, OLADB and SQL Client, and using examples of those. How do you know which one to use? The system.data.oladb library is designed for working with, as you guessed, OLADB data sources. If you don't have a specific provider, you'll often use this one and the OLEDB provider to get at your data. This works with Jet Data from Microsoft Access, Oracle Data, and so on, though I doubt you'd use this with Oracle because you'd most likely use the specific Oracle provider and the Oracle namespace because you'll get better performance if you do. It supports existing OLEDB providers, but it's important to note that OLEDB providers aren't managed code. They run outside the Common Language Runtime. So you're working with COM, basically, to talk to an OLEDB database using the system.data.oledb library. The system.data.SQL client namespace is a managed provider that works only with SQL Server, but it does its work, and all the code runs as managed code within the CLR. This diagram explains how you might use ADO.NET in a multiple-tier application. Not specifically ASP.NET, although we can use it with ASP.NET as you'll see, but ADO.NET works with basically any front end. If you start on the right-hand side of this image, you see the data tier, and that represents the data storage. SQL Server, an Access database, Oracle, an XML file, or wherever the data is coming from. In the middle tier in this example, the business tier, we have code that knows how to communicate with that data tier, and that code is generally called a data adapter. A data adapter knows how, specifically, to talk to a single database source, like SQL Server, Access, Oracle, XML, and so on. Now we need some way to cache that data, to have a class that holds the data and presents it to the user interface as a business object. Now that middle tier class may represent a single table from the data source or multiple tables joined together from the data source. That data object, which is a class, for our intents and purposes can be a data set. And a data set is an ADO.NET object. It has no information about this specific data source. That is, in this image that you see on the screen, the only object that knows specifically something about its data source is the data adapter. Everything else is data agnostic. It works the same with every data source. A data set, as you see in the middle of this image, can contain multiple data tables related to each other. It might contain a single data table. As a matter of fact, the business tier data object may just be a single data table. There's no reason it has to be a data set. But we put that in the image so you know that it could be a data set, which is multiple data tables, which can be related, or it could be just a single data table, whichever you need for your application. More than likely, your application will require more than one data table to be provided to the user interface. So the business tier knows how to retrieve the data using a data adapter and to store that data and expose it to the outside world in some format mapped to the original data store in a data set or a data table. Now that data can be consumed by any number of presentation tier applications. A Windows application, a WPF application, a web form application. All of those can communicate with your business tier. If they're on the same computer or the same network, that data set can be passed around in binary format. If you're talking across the internet, however, you need some way to serialize that data so it can be transported to the client application. ADO.NET takes care of converting that data to XML for you so you don't have to worry about how the transport works. So that XML in the cloud there really could be XML, it could be binary, but the slide shows that it could be serialized as XML for you. On the left-hand side of this image, you see multiple presentation tiers that could be Windows web applications, or it could even be some application that directly consumes the XML. BizTalk Server, for example, that takes the XML from that data set and uses it directly. So you can either, on that presentation tier, rehydrate or deserialize the XML back into a data set or use the XML directly. It's up to the client application to determine that. In any case, this slide is the simplest representation of how you might use ADO.NET in your applications. Note that the only place in here you're communicating directly with the data store is in the data adapter. The data adapter does its work to fill a data table or data set with data and then disconnects. What this doesn't show is sending data back. If you follow the arrows in the other direction, we can send XML from the client app back to the data set, which can then communicate with a data adapter to update changes back to the data store. To get started, we'll need to investigate the data table object. The data table object is the central data storage object in ADO.NET. It represents one table of in-memory data. Now, that doesn't mean it represents a table from the data source. It can map one-to-one with a table. But all I mean here by a table is it contains rows and columns with schema information, kind of like a really fancy array. Where that data comes from, well, that's none of our business. It's your business to determine where the data comes from in a data table. It could come from one table in a database. It could come from multiple tables joined together, returned to you as a single set of rows and columns. It could come from a place that has nothing to do with data. We'll show an example of retrieving information from the file system and placing it into a data table. You can retrieve the data in a data table by retrieving data from a connection, that is, connecting to a data source, or you can manually create and fill the data table one row at a time. And that's what our first demonstration will do. We're going to fill a data table without actually connecting to any data source. I've opened the sample project for this chapter, Accessing Data, and the page we'll need to look at, the Create Data Table.aspx page. And in this demonstration, what I'm going to do is loop through all the files in the folder that contains this page and display them in this grid view control. The way I'm going to do that is by creating a data table object filled with that information and binding it as the data source of this grid view control. Well, let's go look at the code. First of all, you'll note that I have a using statement for system.io here, so it's easier to work with the objects from that namespace. So I don't have to keep typing that every time. There's a procedure called Create Data Table Demo down here that does all the work. It starts by creating a new instance of the system.data.dataTable object. Now here, I need to create the instance so I can fill it myself, and I will point out that you might see the code written this way. And that works just as well. You don't need to provide the name of the class twice when you're writing your code. This code says, I'll make a variable named DT and assign into it what the compiler tells me to put into it, in this case, a data table object. It saves you from typing the name twice. In this case, it doesn't really save us much, so I left it as it was. Now we need to add some columns to this data table, that is, create a schema for this data table, and we'll do that by adding items to the columns collection of the data table. In each case, we'll specify a column name and a column type. We'll use the type of operator to retrieve the type of one of the built-in .NET Framework types, a string and an int32. Probably should have made this be a long int, int64, but for our purposes it's fine. I'm going to create a data row variable, and a data row, pretty obvious, is just one row within a data table. I'll create the variable here, I'll fill it in later on. Now I need to get a directory info object. That's from the system.io namespace that corresponds to the directory which contains the current page. To make that work, we use request.path that gets me the path of the current request. Use server.mapPath, passing that value in to get the actual address, and then I call getDirectoryName to get the directory name part of that address. I create a new directory info object and store it away here in this variable dir. Given that directory info object, I can retrieve a list of files by calling the getFiles method hands me back an array of file info objects. So I'll loop through each one of those using a file info iterator. Here, for each file I find, I'll add a new row. Well, I won't add the row. I'll create the new row, a new data row object, by calling the new row method of the data table. That creates a new row with the schema matching the schema of the table. We'll set the 0th column to be the name of the file info, and the first column, those ordinal values get confusing in this case, to be the length of the file info object. So we've got 2 columns filled in. But we've got a data row, we have to add it to the data table. And you do that by calling the add method of the rows property of the data table, passing in the new data row. And you repeat that for each row you want to add to the data table. So by the end of this loop, having looped through all the files, we're done. One last thing. We need to bind this data table as the source of the data grid. And the way you do that is by setting the data source property of the grid control to be this data table. Now, that doesn't force the grid view control to go out and get the data. All that does is set the data source property. So the next time it needs to refresh its data, it knows where to get the data. To manually force it to perform the update right now, you call the data bind method. The data bind method says, go out now, get the data, refresh your contents, and when I render it, I'll use that data. That's ASP.NET talking. When I render this control, I'll render it with the correct data. So let's go back and let's view the output of running that code. Here you see in the page that grid view control filled in with the contents it got by retrieving all of the file info objects from the path that contains this page. We see the file name and the size in 2 columns, and we did it by filling a data table first and then setting the data source of the grid view control to be that new data table that we created in code. Of course, most of the time you're working with data, you'll want to connect to some data source to retrieve that data. You generally won't need to fill a data table manually. And the data namespaces provide a connection object that allows you to connect to a data source. There's a system.data.oladb.oladb connection object and a system.data.sqlclient.sql connection object. Now, I'm going to refer to these as connection objects, but there really is no connection object. All there are database-specific connection objects, like these classes listed here. Both of those connection objects provide multiple different ways to set them up. For example, they provide overloaded constructors, which allow you to pass a connection string. Or you can just create the connection object and set the connection string later. It's your business. But they do allow you to create that connection string and supply it when you create the instance of the connection object. The SQL version of that connection object has additional overloads. It allows you, for example, to pass user information and data source information as individual parameters to the constructor, making it easy for you to supply everything you need to supply at the time you create the instance of the connection object. Generally, you store your connection information in a web.config file. You don't have to, but generally you do. It's important to note, by the way, if you weren't aware of this, that you can encrypt the content of your web.config file down to specific sections and then have ASP.NET automatically decrypt it. You need to do that if, for example, you don't want anyone to know the path to your database, or even worse, the password to log into your database, which might have to be in your connection string. You can see here that I have a number of connection strings, one for SQL Server, one for OLADB. The SQL Server connection string, the first one, has a provider name, system.data.sqlclient. It's got a connection string which specifies the data source is SQL Express on my local computer. The initial catalog is Northwind. I'm using the Northwind sample database. And integrated security is true. That's just all part of the connection string. The OLADB connection string has a provider name, which is system.data.oladb, and then the actual connection string, which is Microsoft.jet.oladb.4.0, that's the provider, then a data source, which is a path to the MDB file, the Access database I'll be loading. You'll notice that this connection strings section begins with the clear keyword. I added that because if you don't, you might pick up connection strings from machine.config or other web.configs that are higher up in the hierarchy of config files for this site. The clear keyword, the clear element, tells ASP.NET to remove any existing connection strings from higher up in the hierarchy and only use the connection strings it finds in this particular web.config file. In order to set up a connection, you'll generally need some way to retrieve the connection string from somewhere. And in our example, we have code in the common class, a procedure called getConnectionString, which returns the connection string from the web.config file. The web.config file in our example has two connection strings, one called SQL connection string, one called OLADB connection string. You give me the name, that's the name value in this code, and the code retrieves that connection string, and it does it using the Configuration Manager class. There's a connection strings settings object, which we'll get when we use configuration manager.connection strings specifying the name of the connection string we want to retrieve. That hands back a connection string settings object. If that settings object isn't null, then we retrieve the connection string property of that connection string settings object and return the connection string as the return value of this procedure. Given that connection string, we can use it to connect to data. To make the connection, you might write code like this. This creates a new instance of the OLADB connection object. Remember, that's the system.data.oladb.oladb connection object. And its constructor allows you to specify a connection string. When you do that, you can instantiate the object, store it away into a variable, and you must open it before you use it. So this code calls cnn.open before attempting to use the data. We'll use the connection. We'll look more later how to do that. But once you're done, you need to ensure that if the state of the connection is open, and you ought to check also that the connection variable isn't nothing before going any farther. If it isn't nothing and it is open, then you better close it by calling the close method. One rule is, if you open a connection, you better close it when you're done, because connections are a limited resource. You could write the same exact code for SQL connection object. Here, the only thing that's changed is the type of the object. In the first example, I created an OLADB connection. Here, I'm creating a SQL connection. Otherwise, code's exactly the same. Now, if you're going to work with data, you need to take into account that things can go wrong. For example, you try to use the connection and maybe the database is locked. The table isn't available. Something goes wrong. You need to make sure that no matter what, your connection gets closed. So, this code includes a try finally block. The try block attempts to open the connection. If something goes wrong, the finally block will ensure that the connection gets closed. When you were using your connection, something could have gone wrong. Now you can take advantage of the using statement. The using statement automatically disposes an object at the end of its block. For connections, that means that the connection gets closed when it's disposed because that's the way the class was written. In general, a best practice is to use a using block if the object you're working with implements the iDisposable interface. You can look in the documentation to see this. If the object implements iDisposable, then you probably ought to enclose its use in a using block. And that looks like this. Using SQL connection CNN equals new SQL connection, passing in the connection string as a parameter to the constructor. We open the connection, we use the connection, and when we're done, the using block automatically disposes of it. Now, this does not get you out of using a try, catch, or finally block. You still need to use exception handling. Things can go wrong. All this takes care of for you is ensuring that at the end of the block, if things don't go bad along the way, the code will automatically close the connection for you. Just opening a connection is not a very interesting demonstration, so we're going to go on a bit before we actually show some code. Each of the data namespaces expose a command object for executing provider-specific commands, statements that work with the data. There's system.data.sql client.sql command, and there's system.data.oladb.oladb command, and each data namespace provides one of these objects. These are usually a reference to a SQL statement or a stored procedure that does work or retrieves data for you. These objects expose an overloaded constructor that allows you to set some properties at the time you create the data object. Now, commands can do a number of things. They can simply return data back to you. They can execute actions like delete all the rows from a table or modify all the rows in a table that meet a certain criteria. And they can also return a single data item. You can say, let me execute this command and return just a single integer. You'll have to specify the data you want, but it's very efficient to have the command object, if you only need a single data item, have it just return that single data item. To execute those actions, there are some methods of the command object. We'll look at these specific ones. There's execute reader, which executes and returns the data you requested in the form of a data reader. A data reader is a forward-only, read-only, very efficient access to one row at a time of data using the data you've specified in the command object. There's execute non-query, which executes your statement and returns nothing at all. That's what you'd use, that's the method you'd call if the SQL statement or the stored procedure you want to execute doesn't return data, it just performs an action. The execute scalar method executes the query and returns the first matching value from the first row of the data that it would have returned if you'd called execute reader. So execute scalar is the method you'll call to retrieve just a single value back from some data source. Well, let's start by looking at the execute reader method. This method returns a data reader, and all the data namespaces provide a class that represents this data reader. There's system.data.sql client.sql data reader and system.data.oladb.oladb data reader. These are analogous to a forward-only, read-only, server-side ADO record set, which is a way to visit one row of data at a time in order, moving forward only through your data source. And this class, the data reader, is designed to fetch records from the data source as quickly as possible in a stream, handing you one at a time. Now, it's important to realize the data isn't cached except for a single row on the client side. So using a data reader, you'll always get a row, work with it, move on to the next row, and never go back to the previous row unless you write some code to store that data somewhere. The data reader class isn't creatable. That is, you'll never say, create a new instance of the data reader class. Instead, it's returned to you as the result of executing an appropriate method of a command object. So the only way you'll ever get one of these is by executing a command's method. Now, it's important that you close the data reader when you're done with it. Otherwise, it keeps your connection object open, and connection objects are scarce resources in most environments. I will mention that SQL Server 2005 and SQL Express and later versions add a feature called Multiple Active Result Sets, or MARS, that make this less of a problem. MARS allows you to have a second data reader open based on the same open connection. They manage the same open connection, so they don't cause an exception if you attempt to create a new data reader based on an open connection. It's still a good idea to always close a data reader and its connection when you're finished with it, even though newer versions of SQL Server make it possible to work around this limitation. It's like anything else in life. If you're done with it, put it away. It makes things much more efficient in your programming practices. Let's try a demonstration of working with the connection, command, and data reader objects. In the sample project, I've opened the default page, and now I'll click the SQL Data Reader link, which brings up a page which, as you can tell, has read data out of SQL Server from the employees table and has displayed that information in a list on the page. We need to investigate the code to see how that's working. Close this down and get the Data Reader from SQL page and look at its code. The Data Reader from SQL demo procedure sets up a SQL string which represents the data we'd like to retrieve. This could come from any place you want. It could be a stored procedure even. But for now, we're using a simple select star from employees statement. We'll start by using a using statement, creating a new SQL connection object using the connection string from our web.config. Now we also want to use a using statement for our command object. So I've nested a using statement inside this one to create the instance of our SQL command object. And you'll notice I've passed to the constructor of this SQL command object the SQL string, which was created up here, and the connection object. That's one of the many ways I can call the constructor for this SQL command object. So it now has all the information it needs to do its work. It knows what data to work with and where to get the data from. Here, I'll call the open method of the connection. Notice, by the way, that we have a try-catch block around this whole thing. So should anything go wrong in here, for example, if I wasn't able to open the connection for whatever reason, I would see on my page the error label's text property displaying the message of the error that occurred. All right, but I'm assuming nothing's going to go wrong. So here, I'll create a using statement once again for my data reader. And the using statement causes my data reader to be destroyed at the end of the loop. And if the data reader is destroyed, it closes the connection associated with that data reader. So we don't have to manually close the connection. So the execute reader method returns back a data reader, which I'm storing in this variable, containing all the rows we need to look at. And it's really easy to loop through a data reader. The data reader starts out positioned before the first row of data. So you call the read method of the data reader, which moves the row pointer forward one row, gets you a row, and returns true if it succeeded. It returns false if there aren't any more rows. So while dr.read, we'll call the read method, and while it returns true, we'll keep looping. We'll take fields from that data reader, using the index here, to refer to those fields by name. You can also refer to them by index within the collection. That's slightly faster. This would have been the 0th field, the 1, but actually I don't know what number of fields those are within my data reader unless I explicitly list them here. If I had said select first name, comma last name, comma home phone from employees, I could refer to them as dr 0, 1, and 2, but I didn't. So I can't refer to them by number. I have to use the name. And in this case, I'll take them, format them using string.format, and add each one to the list. One thing to note, if you don't want to use a using block for whatever reason, you can also come here and specify at the time you execute the reader that you want it to close the connection for you when you're done with the reader. And you can do that by inserting the command behavior dot close connection enumerated value. That would say at the end of the use of this reader, automatically close the connection for me. Why would you ever use that? Well, imagine a scenario where some bit of code has handed you a data reader. You're not creating it yourself. You don't even have a reference to the connection. You want to make sure you close the connection, but you can't destroy the reader because somebody else might want to do something with it. In that case, you pass it to the user, specifying that parameter, the command behavior.close connection, and the consumer of that data reader, when they get finished with the reader, will automatically close the connection.